Okay, so this is the slope and y-intercept review, just kind of going over everything we've talked about so far this week. This is from Friday, and it's October 16th. So number one says determine the rate of change, which we already know is the same thing as saying the slope, and the y-intercept from the graph. The y-intercept is always what I look for first, just so you don't forget it. And so that is where your slope line, which is this line, the slope is our kind of steep slanted line, and it's when that crosses your y. It might cross your x, but we don't care. We want to see where it crosses the y. And in this case, it's right in the middle. So on this one, the y is 0. Okay, so I've got one of my answers down. Now to get the slope, I have to find two different points, and we can use that point. That's a good point to use. It's just 0, 0. That makes it kind of easy too. And I don't know about you, but it looks like it crosses every little unit, every square. So I've got 0, 0, and then I'm also going to use 1, 1. Okay, and then we're going to use that same formula, y2 minus y1 over x2 minus x1, and plug in what we have and go ahead and label it. So I have x and y, x and y. Since this was the first thing I wrote down, I'm going to put 1s there. That's literally my thinking on it. That's the first thing I wrote down, so that's my 1s. Second one are my 2s. It doesn't really matter, but that's kind of an easy way to do it. And then plug in what you've got. So y2 is 1, y1 is 0, x2 is 1, and x1 is 0. It's kind of hard to say. So 1 minus 0 is 1, 1 minus 0 is 1. So if we divide that or reduce, however you want to say that, we get a 1. That's my slope, and that's your y-intercept. If you want to do something like this, if that helps you, you can do that too if you want your answers to be a little bit more clear. And my light went off, so hold on. Okay, number 2. The height, it doesn't really even matter what the graph is talking about. We are looking for the slope and the y-intercept. So first thing we look for is the y-intercept, and it is right there. That's where it crosses the y. And that is at -4. So my y is -4. And now I've got to find 2 points to look for. So I've got one here and one here. It's nicer to have positive, but if you don't, then that's okay. And so I'm going to use that y-intercept. So that's at 0 because it doesn't go anywhere on the x. And then the y was -4. So 0, -4. And then this other point, it goes over to the 2 on the x and down to the -2 on the y. And I'm going to label these x and y, x and y. This was the first one, so 1, 1, 2, 2. And then our formula. We've got y2 minus y1, x2 minus x1, and then plug in what we've got for those. So y2 was -2. -2 minus -4 for the y1. Now on the bottom, the x's. So I've got 2 minus 0. So 2, it's early, and I'm going to do this on the calculator because math. -2 minus -4 is a +2. And then 2 minus 0 is also 2. And so 2 divided by 2 is 1. So your slope is 1, and your y-intercept is -4. On the back, I'm just going to kind of help with the points on these because I feel like we're good. Here's the y-intercept, and I'm going to use that as one of my points, 0, -3. And I can use this point over here as just another point. Remember, this is your y-intercept. A lot of people they see it cross over here, and they think that's, which ironically is the same number, but it's not. So it goes over to the x, -3. And then it doesn't go up anywhere, so 0. So this one looks kind of funky. But as long as you label it, then you should be good. 1, 1, 2, 2, plug it into your formula. And number 4, this one is always so terrible. Okay, but your y-intercept, we can at least see that. And assuming it goes by ones, which I think it does, that would be positive 1. And that can be a point. So it doesn't go anywhere on the x, but it goes up 1 on the y. And then I feel like that's a point, but I'm gonna be safe and do this one because I'm pretty sure that's a point. And that one is just negative 2, 0. And we're gonna label x, y, 1, 1, 2, 2. Same thing. On this one, I'm unsure of. You may have to check in with me and see what to do about the y-intercept because we can't see it. So I'm going to use these points, negative 5, 0, and then negative 4, negative 4. Okay, now for some tables. If we have a 0, which in this case we don't, that would be our y-intercept. So we're going to have to work a little bit harder on this one. So first thing we got to do is find the slope. And I'm just going to use these two middle points because they're pretty nice. X and Y, X and Y. This is my first one. This is my second pair. And I'm going to plug the formula in. So 43y2 minus y1, 36, over x2, 2.5 minus 2. Okay, so 43 minus 36 is 7. 2.5 minus 2 is 0.5. So if I divide that, 7 divided by 0.5, I get 14, which seems crazy, I know. Okay, so there's your slope. Now we have to find the y-intercept. So I'm going to do like I did on a notes page earlier, and I'm going to kind of recreate the table. And I'm going to start with this 2 because there's 0.5 is the next number up, so I'm going to have to kind of make my own from this. So I've got 2, and across from the 2, the y was 36, okay? And so the whole goal is to work backwards to get x at 0. So if I go back 1, I get 1, back 2, I get 0, okay? So then for the y's, I'm using this slope I just found to go back the same number of times, which would be 2. Okay, I went 2 spaces to get back to 0. So I'm going to be subtracting 14 twice. So 36 minus 14 is 22, and then minus 14 again, and I get 8. So there is my y-intercept. On this one is very nice. You've got the 0, 0. There's your y-intercept. Use whichever points you want, label, and then use your formula. On this one, it's a little bit different. They don't give you the y-intercept, but it's just right there. If we just have to go back 1 to get to 0. So say you use these, and you do 85 minus 70, 2 minus 1. Whatever you get as your slope, you're going to subtract that from 70 one time. So if we get 15 over 1, our slope is 15. Subtract that from 70 because we're just needing to go back one time, and whatever you get will be your y-intercept. So many tables. Same thing on this one. I would do x1, x2. I would use these and remember to go back, okay? So you're at 4, let's see, 4 and 6. So you'll have to go back to 3, to 2, to 1, to 0. So when you find your slope, you're going to have to go back that many times, okay? I feel like 8 minus 6 and 12 minus 4 to get your slope. So we've got 2, 12, 11, 10, 9, 8. So 2 8s or 1/4, or 0.25 is your slope. I wasn't gonna work this one out, but I just realized it's gonna be small and weird. So we were at 6, when we've got 4 over here, we gotta get back to 0. So I'm gonna subtract the 0.25 until I match up with 0. So 6 minus 0.25 is 5.75, minus 2.5 again is 5.5. Okay, so that's with 6, that's with 3, that's with 2, minus 0.25 again. I'm at 5.25 with 1, so one more time, and I'm at 5. So my y-intercept is 5. Okay, I didn't want to do this many, but they're kind of hard. Okay, then I'm going to do slope and y-intercept again. I'm going to use these two, which they're super far apart, but we're going to do it anyway. So negative 44.4 minus negative 8.4 over 23 minus 3. So negative 44.4 minus negative 8.4 is negative 36, and then 23 minus 3 is 20. So when I divide that, I get negative 1.8. So that's my slope. Now I need the y-intercept. And I'm going to start with this one, because that's the closest to 0 that I can work backwards. I mean, I could use negative 2, but I like the positive numbers. Okay, so I've got x and y. If I start with 3, across from 3 is negative 8.4. So to get back to 0, I would have to go 1, 2, 3 times back. So I'm going to subtract the slope 3 times. So negative 8.4 minus negative 1.8 is negative 6.6 for 2. Okay, then one more time, or 2 more times actually. So I'm going to take what I got, subtract negative 1.8, and I get negative 4.8. So now I'm across from the 1. I gotta go one more time, minus negative 1.8, and I get negative 3. So my y is negative 3. That one was tricky. Same thing here. You're gonna work backwards. And honestly, since it's going by 100s, you should be able to go backwards by 100 just the same. Instead of, like, if we subtracted 100 here, since the table's going by 100, you should be able to subtract your slope, whatever you get. Say you use these two. You're just going backwards 1, since these are going up by 100. These are pretty nice too, because you're at 3. It would be just like this, 3, 2, 1. So whatever you get as your slope, you would be subtracting it 3 times. If you need to go back and watch this one again, feel free. I would use these personally to get your slope. So then if you need to, I'm going to write down here, if you need to recreate your table, then it's not so bad. And you would go back however many, or subtracting whatever your slope is. Ton of equations. I think we're pretty confident in those by this point. Remember, box them in, draw your line down the middle, and that should be it. But if you do need help with these, just let me know.